Hello guys, welcome to Computer Science Play Tutorials. Today we are going to learn about bubble sort. We will learn it by example. For example, this is a list. This is unsorted list. We have to sort this list by using bubble sort algorithm. Here sorting means arranging. For example, sorting. What is sorting? Arranging elements in ascending or descending order. Descending order. In bubble sort, we will arrange these elements in an ascending order. Here number of elements is equal to 5. Therefore, bubble sort algorithm passes. In bubble sort algorithm, there will be n minus 1 passes. Therefore, 4 passes. 4 passes. So, first pass. Pass 1. In pass 1, there will be n minus 1 iterations. Therefore, in first iteration, list is like this: 10, 0, 12, 2, 3. In bubble sort, we will compare adjacent elements. If element I is greater than I plus 1, we have to swap these elements. Here, element I is 10. 10 greater than 0. Yes, condition passed. Therefore, we have to swap 10 comma 0. So, the list becomes like this in second iteration: 0, 10, 12, 2, 3. Now, after first we have compared for these two elements. Next we have to compare next two adjacent elements. Next two adjacent elements are 10 and 12. Now we have to compare these elements. Is 10 greater than 12? No, the condition fails. Therefore, no swapping is required. So, for third iteration, list will be like this: 0, 10, 12, 2, 3. So, after this, we have to compare next two adjacent elements. So, next two adjacent elements are these two elements. Is 12 greater than 2? Yes, the condition passed. Therefore, we have to swap. So, for fourth iteration, the list will be like this: 0, 10, 12, 2, 12, 3. So, in fourth iteration, we have to compare next two adjacent elements. These two elements. Is 12 greater than 3? Yes. Therefore, swap these two elements, 12 and 3. So, after completion of first pass, the list will be like this: 0, 10, 2, 3, 12. So, after completion of first pass, the greater element in this list comes to its sorted position. Therefore, this is fixed position for this element 12. This is first pass. After first pass, result is this. So, we have to implement this algorithm for second pass. In pass 2, iterations will be n minus 2 iterations. Therefore, here n is equal to 5. So, 5 minus 2 means 3 iterations will be present in second pass. So, Initially, after completion of first pass, the elements will be like this. Here 12 is fixed one. 12 comes to its sorted position. So first iteration. We have to compare. Again we have to follow same process. We have to compare adjacent elements. 0 greater than 10. No. Therefore no swapping required. In second iteration, we have to compare next to adjacent elements. So in next iteration, these two elements. Is 10 greater than 2? Yes, the condition is true. Therefore we have to swap these elements 10 and 2. So the resultant will be like this: 0, 2, 10, 3, 12. So next two elements. Is 10 greater than 3? Yes, the condition is true. Therefore swapping is required. And the result after completion of second pass. We have completed 3 iterations. After completion of second pass, the result is like this. We have to swap this. So 10, 2. This element is already fixed in its sorted position. Now after completion of second pass, the second greatest element comes to its sorted position. Now 10 is fixed here. Now third pass. So third pass. In pass 3, number of iterations will be n minus 3. Here n is equal to 5. 5 minus 3 means we have 2 iterations. After completion of second pass, the resultant will be like this: 0, 2, 3, 10, 12. And these two elements are fixed in its sorted position. Number of iterations are 2 here, and minus 3, 5 minus 2, 3, 5 minus 3, 2. So first iteration, we have to compare adjacent elements. 0 greater than 2, no, the condition fails. So therefore no swapping is required. Insert no swapping. In second iteration, we have to compare next to adjacent elements. These elements are fixed. So is 2 greater than 3? No. So no swapping is required. And resultant list after completion of third pass: 0, 2, 3, 10, 12. So after completion of third pass, the third greater element will be in its sorted positions. This is fixed. These two elements are already fixed. So next pass. This is last one. Here number of elements are 5, therefore n minus 1 passes means 4 passes are there. So this is fourth pass. Number of iterations in fourth pass, n minus 4. Therefore here n is equal to 5. 5 minus 4 means there is only one iteration. After completion of third pass, what is the result? 0, 2, 3, 10, 12. And up to these elements are fixed in their sorted positions. Now we have to compare these two elements. Is 0 greater than 2? No. So no swapping is required. And this pass is completed and the resultant list will be like this: 0, 2, 3, 10, 12. So these two are also fixed. Now this is sorted list. This is bubble sort algorithm, working of bubble sort algorithm. Now I will explain time complexity and advantages and disadvantages of bubble sort. Time complexity. Time complexity of bubble sort is order of n square. Space complexity. Space complexity is order of 1. And advantages. Easy to understand and implement. It is very easiest sorting algorithm and implementation is also easy. Easy to implement. And disadvantages. If number of elements are huge, if n is high, that is number of elements are higher in number, then implementation becomes complex. Implementation will be complex. So this is about bubble sort algorithm. In next class, I will discuss selection sort. Thank you guys. Thank you for watching my video. Please like my video guys. If you like my video, then my video will be recommended to more students who are in requirement of this content. Thank you. And please share to your friends so that they can also watch my channel and they will improve their understanding. Thank you guys. Subscribe my channel. Please click on bell icon so that my all classes, my all lecture videos will come to your phone. Therefore, you can watch them. You can find them easily. Thank you.